Welcome back to this topic of chemical changes. In this video we're going to talk about the reactions that acids do, and there are three main types that you have to learn. The first type is the way that acids react with metals. You might have done reactions between acids and metals already, and we've touched on them in the section on reactivity. But it's important to know the general equation here that acids react with metals to produce salt and hydrogen. Now, of course, as we saw in the previous section, not all acids react with metals. Only the more reactive metals in the reactivity series will react with acids. So for the purposes of your specification, you need to know examples of magnesium, zinc, and iron reacting with acids. Later in this video, I'll talk in more detail about how we name the acids, but for now it's important to know that when an acid reacts with a metal, it creates a salt, such as magnesium sulfate, and hydrogen gas. All reactions between acids and metals can be called redox reactions. This is when you have reduction and oxidation happening at the same time. For higher tier, you'll be expected to be able to identify which of the substances are reduced in the reaction and which ones are oxidized. When we looked at reactions of metals earlier, we talked about redox in terms of the gain or loss of oxygen. But for higher tier, you also need to know that a reaction doesn't have to have a gain or loss of oxygen to be a redox reaction. We can tell if something has been reduced or oxidized by the gain or loss of electrons. If a substance is oxidized, it will always lose electrons. And if a substance is reduced, it will be gaining electrons. So we use this mnemonic, oil rig, to remember oxidation is loss of electrons and reduction is gain of electrons. So let's have a look at what's happening in this reaction. Well, magnesium is changing from Mg, which is a metal in its normal natural state, to Mg in this salt. And when it's in a salt, it's going to have formed an ion. Magnesium is in group 2 and so always forms a 2+ ion. And so this has gone from a neutral with no charge, Mg, to a magnesium ion with a 2+ charge. If you remember going back to ionic bonding, the way that elements become ions is by losing or gaining electrons. So in order to go from a 0 charge, a neutral charge, to a 2+ charge, the magnesium has to lose electrons in order to become more positive. So in this reaction, the magnesium has lost 2 electrons, and that means, because oxidation is loss, that it was oxidized. So let's have a look at what must be reduced. Well, we can see that in this substance, H2SO4, the SO4 is the same as the SO4 in the magnesium sulfate. So the sulfate part hasn't changed. But the hydrogen in this substance has changed into hydrogen gas over here. When hydrogen is in a compound, it's also an ion and it has a +1 charge. When something is an element, it never has a charge. Elements are always neutral, and so it has a charge of 0. We can see that to get from +1 to 0, we need to add a negative charge, so this hydrogen has gained electrons. So we can say that it's been reduced. It may not be completely necessary to work out all the details depending on the question. If the question is simply which element is oxidized and which is reduced, then you can remember the pattern that in reactions of metals with acids, the metals are always oxidized and the hydrogen is reduced. Now let's have a look at the other reactions that acids do with metals and their compounds. So, acids will react with metal oxides, metal hydroxides, and alkalis in the same way. This is because all metal oxides and hydroxides will neutralize acids. We call them bases. A base that can be dissolved in water is called an alkali. So bases and alkalis will react with acids by neutralizing them to produce salt and water. So this is slightly different to what happened when you had a metal by itself, which produced hydrogen. Now, as well as the salt, we produce water. Acids also react with metal carbonates to produce salt and water, but because the metal has a carbonate as part of its compound, there's another product this time, and that's carbon dioxide. You're expected to know the general patterns of reactions with acids in this way, and you may be asked to write an equation for any of these. In order to write an equation, we need to be able to predict what products will be produced from the reactants that we're given. And in order to write a chemical equation, we'll need to know the formulae of the ions that are involved. So let's first of all look at writing word equations. We've said that when acids react with metals and their compounds, that they make salts. The name of a salt will depend on the type of acid used and the positive ions in the base, alkali or carbonate which reacts with the acid. The most common acids are hydrochloric acid, which reacts to make metal chloride salts, sulfuric acid, which make metal sulfates, and nitric acid, which make metal nitrates. There are other types of salt, but these are the most common ones you'd be asked about because these are the most common acids used. So for example, if we had magnesium reacting with sulfuric acid, to name the salt we take the metal from the metal part of the reaction, and we take the sulfate from the acid part of the reaction. And you need to remember what the reaction will also produce, and in this case, because we had a metal reacting with an acid, it produces hydrogen. If we have zinc oxide with hydrochloric acid, we know it will produce a salt and water, and the salt will be called zinc because we have zinc in the zinc oxide, and chloride because we have hydrochloric acid. If we have something like lithium hydroxide, we can see the hydroxide and the acid will make a salt and water. And to name the salt, we have lithium from the lithium hydroxide and nitrate from the name of the acid. So once you can write the word equations, you may then need to write the symbol equations as well. So chloride salts will always have the Cl- ion in them because chlorides come from chlorine, and chlorine always produces a 1- ion. Sulfates will have the SO4 2- ion in them. Remember when you're writing the formulae of ions that the SO4 has a small 4 below the line, we call it subscript, and the charge of the ion goes above the line, we call it superscript. So just remember to write that in the right way rather than SO4 2-, which would be marked as wrong. When nitric acid reacts to make a metal nitrate, it will always include the formula NO3- for nitrate. Again, remember to write the number of oxygens below the line and the charge of the nitrate ion above the line. So see if you can predict the name and the chemical formula of the salt that will be formed in these three reactions. Okay, so in reaction 1, iron oxide will react with sulfuric acid to make iron sulfate, and of course, because it's an oxide with an acid, it will also produce water. The formula of the salt will be iron for the iron sulfate, which is Fe, and then the SO4 ion for the sulfate. In this case, iron, Fe, is normally a 2+ ion, and SO4, the sulfate ion, is normally a 2- ion. So they cancel out and we only need one of each, so no extra numbers are needed. Zinc will react with nitric acid to make zinc nitrate plus hydrogen because we have a metal reacting with an acid. And the formula of the salt will be Zn for zinc and NO3 for nitrate. But here we have to be careful because zinc is normally a 2+ ion and nitrate is normally a 1- ion. So we'll need two of the nitrates to cancel out the charge of the zinc. To write this properly, we need to put the nitrate section in brackets and we need to add a small 2 afterwards to show that we have two of these nitrates which have a 1- charge and one of the zincs which has a 2+ charge, and now that's the correct formula. If we had magnesium hydroxide reacting with hydrochloric acid, we would have magnesium chloride formed plus water, and the formula of the magnesium chloride will be Mg for magnesium. Remember that because it's in group 2, it's a 2+ ion, and so Because Cl is a 1- ion, we need 2 of them to make the formula correct. So there we have the names and formulae of the salts made in these different reactions between acids and metals and their compounds. Here is a list of keywords that you might find useful. Thanks for listening, and see you again soon.